to a fraction by different numbers, guess what? That's why we laugh, because your face looks distorted, right? Because you scaled up one part longer, and then you scaled up one part shorter. So when you scale up or down, it has to be the same number, right? Because 5 over 5 is 1. It's a great question. It's a great question, because like, what do you mean by value, right? These are just not digits. Equal signs means that there's something on the left and something on the right that has to have exact same value, no matter what you do to it. Okay, no matter what you do. I can multiply by 50, and it will still be the same value. Okay, the top and bottom. Fractions are the hardest thing for kids to learn. I have a story of a young woman. She's actually really smart in everything she's done. She hung up on fractions. I had her for 6th grade. I had her in 7th grade, and she never quite got it. And then one day, I think either we were doing stuff in scaling where you are drawing pictures and you make it bigger and smaller. She stood up in the middle of the room and just said, I got it, I think I finally got it. I said, what did you get? She goes, I think I finally understand fraction. Okay? Because it's hard, you have two numbers changing at the same time. Okay? I don't know if anybody explained that, right? That you have two numbers changing at the same time, that you have to think together. Okay, you have to think of those two numbers together. So for children, it's one of the hardest things. Now, a lot of them can do the work, but if you don't understand why, that's how you make some of the mistakes, right? If you just do it without actually understand why, then you're doing it, and then when you get an answer that is wrong, it's not because you didn't know how to mechanically do it, you just didn't understand that 9 over 5 could never be 5 in 1/4. Never be. Right? So that's the logic. Very good. Thank you for doing that. Thank you for kind of a modeling, because sometimes by mistakes you actually learn a lot, right? By your mistake you learn a lot. So anything in algebra that somebody wants to do? You were talking about graphs. What about graphs? Does anybody? What about graphs that is hard? Any problem? Any one of the problems that you want to just try? Maybe somebody can help too. Can I erase this? And now I want to get into geometry. You want to just pick one, and maybe somebody else who has done it can show it. You want to pick a problem? It's like the next graphing equations and inequalities. This whole graphing. So we are talking about graphing equations and inequality. So graphing, again, if you think about it, it's about two numbers changing at the same time, right? Because it's a relationship between, which one is x? Horizontal. And y is the vertical, okay? And you know how I remember? Y is just a little tail, so it's longer. That's how I remember. Just anything that helps you remember, okay? X is this way, and y is this way, okay? And then when you have coordinates, it's the first number, like when you say coordinate of 3, 2. Which is x and which is y? Yeah, x comes first and then y later, okay? So that's the, so, and it makes sense because x comes before y, so that's another way to do it, right? X comes before y. So if you think about algebra, I think I mentioned that the last time. Algebra is about relationship between two things that are changing. Okay? You have x that is changing, and then you have y that is also changing. And so algebra is really the study of those relationships. And they get more and more complicated. So sometimes it's linear. Like if you go up by 1, I go up by 1. If I go up by 2 here, I go up by 2. That's a linear equation. In the sense that linear means that the relationship is very much like, not so 1-to-1, but rather if I increase by 2 here, then I increase by 2 here, so that's where the straight line comes in. Okay? When you start getting into very complicated equations or relationship, you may have heard about this. Some things people will say word like, oh my God, this is exponential. Okay? What that means is that when something increased a little bit over here, it increased a little bit over there. But then when this go up more, this jump really big. And then when this go, it jumps really, really big. So in everyday life, we talk about exponential. It means that the relationship is just that the little increase on one end, of the x, has a big increase on y. And it gets bigger and bigger. Okay? So relationship between the two variables is how I mean, you will only be tested, I think, for linear equation, I think, but I might be wrong. That this is linear, okay? That you could actually predict what goes here and what goes up here is exactly the same each time. That's what linear means. Okay? It's like walking stairs, all right? That whatever you go one way, you go up another way, all right? So this is x. Actually, they call it delta, like change in x and then change in y. Okay, that little symbol is. So the changes are exactly the same every time. But what happens when you have a relationship that is, say, this way, right? So what happens is that over here, if I change this part, this is delta x, this is delta y. But if I come here, the same amount, let's say if I look at the same amount, look at how much more I change. See that? So that's what it means, a different relationship. Okay? So I want to throw in the word relationship so that you're not thinking of like algebra is all about equation. The equation defines the relationship. Okay? The equation defines the relationship. So the idea is that when something is exponential, that's just a term that people use a lot, it means that the same change early on gives you very small change in the vertical. But then later, as you keep going up, oh my God, it's changing so big that I can't even draw it, right? For the same amount. Okay, if you think about the same amount, it's changing a lot more. Okay, so that's algebra basically. So when people start talking about calculus and all that, it's more in-depth algebra. Okay, it's all algebra. Okay, it's just that it's different topics in algebra. Okay. All right. So how do you plot a graph? Oh well, no, this one is not about plotting a graph. What is this supposed to do? But yeah, what problem did you want me to do?
What packet is it?
This is the algebra packet.
Or the back?
Two at the back. Yeah. Ah, right here. So on the second page that says graphing equations and inequalities, there is a problem on this side that says the graph of x minus 4y equals to 4 is found by plotting the intercept points of 4, 0, and 0, 1. Drawing a straight line through the two plotted points. Yeah, last page, second last page. I know this one have no numbers to start with.
Third to last page.
Third to last. So, you know what, this might be, some of you may know this mechanically, so it might be a good idea to do this. Just so that even if you know it, maybe it's a different way to explain to you about this. X minus 4y equals to 4. Okay. Now, when I look at this, I know that it's going to be a straight line. How do I know that? So I don't know how many of you remember.
Plus 4, right?
How many of you remember this ax plus b? That's a linear equation.
I don't.
Okay, so if you want to write that down, okay. The reason it's linear is that there is a 1 here. That means the changes is going to be whatever x, like the changes are constant. They're the same change. If you put an x here, you know the y, and if you put an x, you know the y, and the change is the same. So I'll show you what that means, okay? So it's a linear equation partly because there's no, like if I say this, x squared minus 4y equals to 4, right away I know this is not linear because of the square there, okay? So when the expression have nothing that has it's all ones, right? That means it's a linear equation. And you can prove it, and we can try that. So whenever I get something like that, I like to change it in this format because like we say, the whole idea is to say, how is y changing when x is also changing, right? So y is the vertical and then x is the horizontal. So what it's saying is that when x changes, y is also changing. So how might I change this into this format? So let's try that, right? How do I change it in the format? That means I have to isolate y, right? So what do I do with the x? I want to move it on the other side, right? So I want to subtract x on one side, which is moving to the other side. So x minus 4y equals to 4 minus x. Is that correct? Because I want to get rid of it. I always put a little thing just to make sure that I got the sign correct. Yeah, I want to get rid of it, so I'm minusing x here to get rid of it. But then I have to do it on the other side to balance. Again, the left and the right, I haven't changed anything. I just rearranged some terms. Okay? So then what am I left with? Negative 4y equals to 4. 4 minus x, right? I almost took that out. 4 minus x. Okay. So now I want to keep it in this format.
So you divide by -4?
Yeah, I can divide by -4. But then when I do it on this side, do I only do it on one of them or both of them? Both, because you have to look at this the whole thing and then divide it by -4. Right? Or you could write it the other way too. -1/4 times 4 minus x. You can write it that way too. You can write it that way. Right? Divided by -4 is the same as multiplying by 1/4. Right? So this one, the -4 and -4 go away, and I get y. That's the easy part. What happened to this side? Which one do you like? Let's say I use this one. What is this? What we have to do? We have to open up the brackets, distribute it, share it. So we're going to share 1/4 with 4 and share 1/4 with x. Okay? So -1/4 times 4, what is that answer?
1.
Is it 1?
Yeah.
Is it 1 or?
Or -1? Is it? No, 4.
So -1/4 times 4.
4.
-1. Remember, you've got to carry the sign. Okay? 4 over 4 is 1, but then there's a negative in there. Right? And then here, this is the tricky part. You have a -1/4 times, so these are all times. Okay? When you distribute, they are times. -1/4 times a negative x. What is that?
Positive x.
Yeah, that's the tricky part, right? 1/4 x. Okay, somebody's looking. Okay. Speak out loud.
I'm sorry, I just don't understand how -1/4 times 4 is 1.
Okay. So think about it. -1/4 times 4. 4 and 4.
So you can cancel it out before you even distribute.
In fact, that's what I'm doing, right? When I distribute, so what I'm doing, maybe I should put this step here. The step in between is that I'm distributing 1/4 to 4 plus 1/4 and x. That's what I'm doing. Yeah, 1/4 minus x. That's what I mean by distributing. 1/4 goes with 4, and then 1/4 goes with negative x. That's what distribution means. Okay? So then -1/4 times 4 is, cancel that, is -1. You have 4 pieces and you divide by 1/4, by 4 people, you get what?
Okay, so what if the 1/4 was 1/2, so that it would be 2 negative?
Yeah, yeah,
Yeah.
yeah. So this will be -1. And then because it's a negative and a negative, it's just x. You can say x over 4 too, you can think of it this way. So x over 4 is the same as 1/4 x.
Oh,
Right?
yeah.
You gotta like go back and forth because on the test, they may give you this or they may give you this. You don't know. You have to know both. divided by something is the same as multiply by 1 over something. Do you see what I'm saying? So when you divide it by 4, okay, when you divide by 4, is it equal to multiply by 1/4? Do you see that? When you divide by something, it's the same as multiply by the fraction. This is very important. So when you divide by 4 here, right? What I just did is say I'm dividing by 4. It's the same as multiplying the fraction. So this is a very important thing to know. When you divide by something, it's the same as multiply by its fraction. Because when I divide by 4, I'm sharing four things. Or I could think of it as, well, I'm going to split it into 4. Like, what is $0.25? It's 25 cents, right? So I could either say, $1 divided by 4, or I could say $1 times 1/4. They give you the same answer, right? They give you the same answer. So divide it and multiply by the fraction is the same thing. And that's a very important concept because on test you don't quite know what they're going to show you. You're going to understand both. Okay? So what is the final answer? We did it like 3 times here. So what is the final answer? Now I want to put it in this form. So y equals to a. What is a then? Look carefully. -1 plus x over 4. And a goes with something that has x on it. A will be actually, what is A?
1/4.
Minus 1.
What is A? Well, let's see what is B first. Remember, X is the one that has the A in front, and then this one is just a number. So if I have this, or this, how do I make it look like y equals to ax plus b?
1/4 x plus minus 1.
Yes.
Right?
Yes.
Equals minus
Yeah. So A in this problem, right? A is equals to 1/4, and B is equals to -1 or -1.
Is that because of x is there already?
Huh?
Is that because of x is there already that we can assume?
Where is x equal to 0? Where are you seeing that?
1/4x?
1 over 4x. There's a multiply here, right? Remember, 1 over 4 times x is the same as x divided by 4, right? So what you want to do is to say, how does this match onto this form? And there's a reason for it. That means mathematicians did this so many times that they realized that every linear equation can look this way. And when you actually can see it this way, there are a lot of things that you can draw from it. And we'll see that in a minute. So y equals to ax plus b. Y means like what is the value changing? A is how steep the line is. Okay? A is how steep the line is. And then B is where it starts. That's called the intercept. Okay, so this is called the y-intercept. And I'll draw that to you. This is called the slope. So B is a y-intercept, A is slope. And that is something that every linear equation has this form. Every one of them. Okay, every one of them. So now I just did this to get it into this form. We haven't even plotted it. We haven't even done anything. Okay? We haven't done like drawing or anything like that. But getting it into this form will help you draw it. Okay? Getting into this form will help you draw it. So when you think in everyday life, what is a slope? What does slope mean? What does slope mean? Something is like slanted, right? Like when I walk up the stairs, right? I keep kind of going like up, or sometimes I go down, right? So slope has something to do with how steep something is. Okay? So in mathematics, slope is defined by how much you are changing on the y over how much you're changing on the x. Okay? So slope is equals to delta y over delta x. That's why fractions are so important. That's the reason why you do so much fraction, because in algebra, the slope has everything to do with fraction, right? If you think about it, if I walk 1 on the x and walk 1 on the y, it's 1 to 1, all right? 1 to 1. When is it really steep? What if I walk 1 over here, like which is steeper? This one or this one?
First one.
First one. And why is that steeper? Because the y is longer. The change in y, so this is the delta, right? Change in y is a lot bigger compared to the change in x, right? So when the y is a lot bigger than the x, it's really slow. If you think about stairs, that's a tough one to walk, right? Now, what is the other direction? Will be this way, right? When the change in x and the change in x, sometimes you have those where it's like, oh, it's a big long thing, and then you have a little bitty step to go up, right? And they do that in parks because so that people who are maybe can't walk very fast, they do it here more than they do it this way, right? They do it this way, so that there's little baby steps that you walk up, okay? So this slope. So if of all three of them, which one will have the biggest slope? Just by visually, which one? So in the order of biggest slope, so in that order, biggest slope, 2, right? And then 3, and then 1, right? So rank, you want to say rank, right? This is very important, because you know what? Sometimes people know slope by technically entering some numbers, but I would like you to understand it conceptually. It makes sense in real life, okay? Without even knowing numbers, you know that this one is the least slope, least steep, right? The slope is the smallest. This is the biggest slope, right? Because it's so far to walk for each of the little x that you have, so big. And then this one, maybe it's about equal. Okay, maybe it's about equal, all right? So if you look at this relationship, does everybody understand that if I have y here and x here, and I have it right in the middle, what is that line called? What is the equation? What is that equation? That is exactly the same on both sides. What is the equation? So if I go on 1 here, I'll do 1 here. If I do 2 here, I'll do 2 here. So how do I write the equation?
Y equals X.
Yes. Yes. Okay? So this is always my standard. Very good. This is my standard. So remember that one. Because every linear equation is either going to be steeper than that or less steep. Does that make sense? Right? So either you are going to be like this. I meant to draw it so that it's equal. So let's just make sure I can draw it equally. So this slope means that when I change 1, I change also 1 in y. If I change 2 in x, I also change 2 in y. So this slope is 1 to 1. Okay? So if I say I have a slope that is smaller than 1, where would the line be? Would it be here or would it be here? If I say that the slope is smaller than 1.
Going to the
Here or here? Smaller than 1. Remember what we said? When the slope is smaller, okay? Yeah, when the slope is smaller means that you could walk 1 here, but then you don't go all the way to 1 because it's smaller. So this, okay, will be a slope that is less than 1. So this is slope equals to 1. Okay, this will be slope less than 1. Okay, so what happened when the slope is more than 1? It will be very steep. Okay. And then this one, the slope is bigger than 1.
So in this case, y would determine how big the slope is?
What's that again? No, this actually determines how big the slope is. So you think
I'm
about
talking about the graph.
the graph, okay?
So the more the slope goes to the y direction is
Yes, the slope is bigger.
the
Because
okay.
Because you're saying that for the little bitty that I go horizontal, I got to go really a lot more in the vertical.
When you say bigger, you mean steeper, right?
Steeper, yes, I'm sorry, yep. So, thank you. So when I say the slope is bigger, that means it's steeper, all right? So maybe, English, big slope means steeper. Okay, so think of it this way, right? Big slope means steeper. So the bigger the slope, the steeper it is. Okay? So we're not done yet. So yeah, we're not done yet. So when I look at this problem, so I need like bigger board, but that's okay. I need a bigger board. So can I erase this? Does everybody have Nicholas?
Yes.
Okay. Oh, this doesn't erase one. Wow. This is like, did he have a permanent one?
You can use dry erase over it and erase.
Oh, really?
Yeah.
That's weird. So, remember, I wish I had different color. Remember we say that x equals to b. Oh, plus b. So, may I ask you, when you have y equals to x, what is the slope here?
Equal.
Equals to, a is what? When y equals to x, what is the a here? Oh, thank you. A is 1. Your slope is 1, right? That means the ratio between the x and y is exactly the same. Thank you. All right? So if I look at how y equals to ax plus b, that means a is 1 in this problem. A equals to 1. And what is b? Is there anything there? 0. Okay? So the reason you want to understand this is that you always want to be able to look at the equation and say, what is the A and what is the B? The A tells you the slope. In this case, well, the slope is exactly in the middle, 1 to 1. The ratio is 1 to 1. I move so much in X, I move so much in Y. Exactly, 1 to 1. Okay? And then B, this is the part. B tells you where you start. It's when it says 0, that means you start right here. Okay? Right? If that number was 1, that whole line moves up 1. That's why it's called the y-intercept. Y-intercept means that where is it on the y-axis? So this has very specific meaning. Okay? It has very specific meaning. For this equation, B is 0. That means it never intercepts y at all. It started at 0. Okay? So if I say, so let's start with, because this is so fundamental. What if I say y equals to x plus 2? Where would the line be? If I say y equals to x plus 2. Look at the form again.
than the
Is it steeper? Let's look. Y equals to x and y equals to x plus 2. Are they the same level of steepness, or are they one is more steep than another? Y equals to x, y equals to x plus 2.
Y is steeper.
Or is it? I don't know. I'm asking.
It's the same, but the starting point is to start from 2 instead of 0.
Yes. Did everybody see that? I have not changed anything in the front of that. Because I look at y equals to ax plus b. For this one, what is a?
1.
It's still 1.
Yeah.
When the slope is still the same, that means the line is exactly the same. Okay? Except that now it's going to start at 2. It's a y-intercept. So what is going to happen is, this is where I would love a color. Thank you. Without even putting a table together, by putting it here, I know exactly that the slope is the same. It's just that it's going to start at 2. So guess what? It's a parallel. Oh, that didn't work. Uh-oh. We'll find out. We'll keep finding. There you go. So that line, okay, is y equals to x plus 2. This line is y equals to. Okay?
Oh, so instead of if y equals 2x, then it is.
Oh, if it's 2x, then it will be the steep line, right? So knowing exactly what this is tells you whether it is the middle line or something that is deeper, something that is not so steep. So when you have a quarter, right here, this is our we are still talking about this equation that we did. If you look at this line, okay, forget about whether it's showing this way or the other way, all right? Because when it's negative, it goes the other direction. Do you know that if this line is actually steeper or less steep than slope equals to 1? Less, right? Because it's a quarter. The A is a quarter, right? So in this problem, A is a quarter and B is minus 1. Oh, B equals minus 1. So B equals to minus 1 means that the line starts at the bottom. Okay? This is one of the most fundamental algebra problem. So somebody did a lot of tables, and every time they plot it, it comes up with the same thing. So over time, this equation become like, that's the relationship. That there's a relationship between y and x, and the slope tells you how steep it is, and b tells you where it starts. Okay? This is the beauty of
X is really important to, no, I mean, A is to X as Y is to B.
Not quite. The slope has to do with the relationship between x and y. Like when I go up x a certain amount, how much am I going up in y?
Right, but you
Okay.
keep telling me that it should be X before Y, and then you said X is the horizontal versus Y is the vertical, but then you say A is before B.
Yep. There are a few things here. So when I say that when I say that y is the vertical and x is the horizontal, it has to do with how you define the coordinates. This is standard in the whole world. That I could take an equation and people know that x is this way and y is that way. And then when I say x before y, okay, for example, 2 and 3, across the world, people will know that the 2 means I go this way 2, and then I go up 3, right? I go up 3, right? That has nothing to do with the slope. That just gives you 1 point on the graph, right? There are many points. See that? 1, 2, 3, 4, 5, 6, all the way to infinity, right? The relationship of y equals to x means that whatever x is, y is exactly the same. But here it says that whatever y is, x is exactly the same, except that I have to move 2 more because I started higher.